Okay, so in the last video we were going through this, I had to stop it because there's only so many minutes I can talk through for YouTube to upload my videos. Okay, so we left on Z. After that unconformity, we have F being deposited, I, and D being deposited after that. So we have F, I, and we have D. Okay, so above D we have what? So above D officially we have R, but we see that R is an unconformity that is also on top of B. B itself has been cutting through F, I, and D. So that means that B has to come after D, but before R. So we have B, and above it we have again R, that is the unconformity. In this case, R would be a disconformity if you were looking at it right here, but it would be a nonconformity if you were looking at it right here, right? Because it's above an igneous body. Okay. Above R we have H, and then A, and then Q. Nothing too crazy about that. H, A, and Q. And then above Q I have this unconformity right here, which I don't see a label for, but there is one somewhere. Well, maybe not. I think it's supposed to be P. However, oh, there it is. Never mind. P is going to be the layer itself. The unconformity doesn't have a name, or a letter assigned to it. But if it did, it would come right there. Then P would follow it. So I guess this would just be P. Above P we have possibly C. And then above C we have Y. So the reason that I think that C comes before Y is because of the principle of lateral continuity. So I believe that C should have been laterally continuous this way, and then some sort of river or something along those lines carved that canyon in between, and then after that canyon was formed, Y got deposited. So that's why I believe that that's the order in which they go. So just to review on our unconformities, this first unconformity, unconformity Z, would have been an angular unconformity, right? Because the layers underneath it are tilted, and then the ones above it are horizontally and sedimentary. As I said, R, it depends where you look at it. If you look at between D and H, that would be a disconformity. But if you look at it between H and B, that would be a nonconformity. And then the last unconformity, which is not labeled, would be also an angular unconformity because all the layers that come in below it are angular or are tilted or folded. So that makes it an angular unconformity. There's also another unconformity that was not referred to, which is this bottom one. So this bottom one, it's also a bolded squiggly line. We didn't name it anything in the diagram. But you see that the body that is below it is an igneous body. Those kind of hash marks like that, those mean that it's an igneous body. So because it's on top of an igneous body fully, it's a nonconformity. Okay, great. So I give you the answers for that. How you're going to submit it is through the following way. Okay, so once you have finished that diagram that I give you the answers for, look at my husband, he's doing the diagram. Okay. Anyways, so once you have finished that diagram that I give you the answers for, as well as the other ones that you should have also had answers for, and then the remaining of the quiz, the lab, which we'll go over, you come onto the topic module for geologic time. Below the instructions again is the link for the quiz where you submit your answers. So if you click on that link, it will take you through how you normally submit quizzes and exams. So you click begin, and because these diagrams don't have a label, they don't have a number assigned to them, I have the questions for parts 2 and 3 before them. So the diagrams you'll find at the bottom of the quiz. So the first diagram, which again is the one I give you the answers for, is right here. Question 17 officially. Okay, question 18 officially. So we can go through this one answer together, and you'll see that what we said was correct. So I had said the oldest thing was E. Oh boy. Well, this is going to take me a while. So you will see that what I gave you is the correct answers. So I might lengthen the time to submit this quiz, given just that I just saw how long it would take you to input these answers for each of those diagrams. So I might lengthen the time that you have to submit the quiz. Okay, so you see that's where you submit all the 4 different diagrams that you have to do. That's how you do that. Okay, so you complete those 4 diagrams just the same way we went through the first one. This is the first one, second, third, and fourth. That fourth one is on page 92. And then you move on to part B. So part B is relative dating with fossils. And it's going to be a little bit not as fun as it would be in the lab, because in the lab you actually get to see the fossils and recognize them based on little booklets that we give you. But you will still be able to complete this with the key to the names of the fossils that you're supposed to identify. So I'm going to go through this with you. So before the discovery of radiation and the development of radiometric dating techniques, geologists had limited resources to resolve the ages of rock units. Even today, the analytical cost of radiometric dating can be tough on the thin research budget. In sedimentary rocks, examining the fossils and groups of fossils can be a very powerful tool for geochronology. So in this exercise, we will be examining the fossil assemblages of some sedimentary rocks to determine their age. So, again, this part you're not going to do. You're not going to obtain a fossil kit from me, nor the ID booklet. So I'll just give you the names for those samples, or for those, I guess, items. So, in this case, you will use the correlated geological timescale, which is on figure 1, or the next page. So it will be this one right here, okay, on page 95 of your book. So you will be using that one to complete the rest of this. So you have 3 samples, 3 hypothetical samples of rocks. They won't be, obviously you won't look at them, nor did we have them in lab. They're hypothetical samples that contained an arrangement or an assemblage of fossils in them. So what you must do is identify these fossils, which again you cannot do because you don't have the fossils. I'm going to give you the names, and then you'll be able to, while using the times or the periods during which they lived, you'll be able to tell what period that sample belongs to in geological times. So let's do that. Okay. So this first one, it says, sample 1, this rock contains fossils 23, 32, and 24. Those numbers are not important to you right now. So what are the names and ranges used geological periods for each fossil present in this rock? So number 23 is crinoid. Okay, oh, you'll need that, maybe. Crinoid. Number 32 is Herbertella. And number 24 is Blastoid. Okay? So if you go back to your figure on page 95, you will see all of these in the picture. I'm not going to tell you where they are, nor am I going to show them to you right now, because that would be a little bit doing the work for you. But you will see those organisms within that figure, and you'll see that in the period, which is to the left of that figure, they will have spanned through a range of periods. So for example, a different organism like sharks started being present in the Devonian, according to the picture, and go all the way to the Neogene, which is present time. Okay, so that's how you'll do it. So you'll say, for example, crinoid will have gone from Cambrian to Cretaceous, which is not true, but that will be what you will put in that answer. Okay? Good. So for the second sample of rocks, you have samples 10, 36, and 37. So in this case, the names for these samples are brachipod, you have brachiopod 2, and then you have ammonite. Okay, so during what period was this rock formed? So basically for this question 2 and question 4, what you will do is you will look at the ranges through which all of those organisms in each sample lived together, lived at the same time, and that will be the period that you put in the answer. Okay. Oops. And then lastly, for sample number 3, which my face is covering, let's move that. For sample number 3, you have items or samples number 4, 31, and 16. So those samples are Antherzoa, you have Turritella, and then lastly you have Archimedes rhizoa. Okay. And so for this one, you will do the same thing that you did for questions 2 and 4 for question number 6. But in this case, you won't give me the period. You will give me a span. You will give me the ages of said period or periods during which the Antherzoa, Turritella, and Archimedes rhizoa all coexisted. Okay? So that's pretty much the end for part B. So fairly straightforward. And then in your quiz, it will look something like this. So you see that question 1, which is correspondent to question 1 of your lab manual, asks you the names and the ranges of periods during which those organisms lived. In this case, I actually showed you the organisms, or at least pictures of them, so at least you saw some part of the lab that we wanted you to see. I give you again crinoid, Herbertella, and blastoid as the 3 organisms that you had for that sample. And then I give you different options as to which periods they could have lived at. So you click the likeliest or the most likely option based on your deduction techniques from figure 1. So you do that for all of them. In this case, for question 2, the overlap ranges, you give me the period that corresponds, and you do that for the remaining questions. Okay, so question 7 is where we start part C of your lab manual.